welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am an associate professor, Department of Computer Science, Aryabhat College, University of Delhi. So in this series of our Java language, presently we are going through a topic of multi-threading, and in last few lectures what we have gone through, I'll just make you recall in within 1 or 2 minutes. So we have seen what actually a thread is, what is the utilization of thread, that is for in order to implement the concept of multiprocessing. Then we have seen some very small concepts which are going to be used in our subsequent lectures, which are synchronization and messaging, the communication between the two threads. And then in this last lecture we have seen how to create the thread. That means through which particular or through how many in how many ways we will be able to create different threads within a program. So basically there are two ways through which a thread can be created. One is to extend the thread class, and another one is to implement the interface runnable. And how to implement the interface runnable, we have seen that with the help of a program in our last lecture. So today we are going to take forward the concept of multi-threading, and what we are going to take up here in this lecture is about how to make a multi-threaded program, or how to implement multi-threading using the second way, which is about extending the thread class. So second way to create a thread is to create a new class, and that new class will be extending the class thread, and then we will be creating an instance of that class. That we will see with the help of a program also. And as you if you remember that we have used one particular method, which was the run method, and that was available in the interface runnable, and that run method we have used in the class which was there kind of implementing the runnable interface. Similarly here also, this extend the class which is going to extend the thread class must override the run method. Why this run method is important in both of the methods, one related to interface and another one related to inheritance, because this is the entry point for the new thread. So whatever new thread you are going to create, your run method is going to be the entry point for that particular thread. And also, in order to begin the execution of the new thread, we have also seen the usage of the method start. So basically two methods are there. One is the run method, which must be overridden by the extending class because it is the entry point for the new thread, and in order to start or in order to begin the execution of the new thread, you must call the method start. So with this background, and we have also seen usage of run and usage of start in our previous methods. So here what is going to be the different thing is, earlier we have implemented the runnable interface, and this time we are going to create a thread with the new way, we can say, which is extending the thread class. And here is the program. So we have taken one class new thread. The class has been named as new thread, and this is going to extend the class thread, and this class thread is having so many methods which are going to be used for this implementation of the whole threading thing. And now with the constructor new thread, we are going to create a new thread, and that new thread is being named as, or kind of is what I can say here is being labeled as demo thread, and we have supplied that name in the form of a string inside super. So super here, as you all are aware, that super is calling the constructor within the constructor. If we are going to use the super keyword, super is calling the constructor of the parent class. So parent class here is the thread class. So thread class's constructor is being called, and immediately this is going to create one more thread which is being labeled, which is being tagged as demo thread. And we are going to print the name of the or the label of this child thread by using this pointer. The usage of this pointer also we have kind of done in detail in our previous lectures, and after kind of creation of this particular thread, which is the child thread, we are going to start this thread by using the method start, and here we are going to end our this thing and the constructor. So, within the constructor we are calling the super classes constructor, we are printing the label and we are starting the thread. So, these three steps or these three things are to be done inside the constructor of the class, which is extending the thread class. Moving forward, we need an entry point for the second thread, and entry point for the second thread, obviously as I told you just now, that this is going to be the run method. So, we have a run method, and the syntax or the signature of this run method says it is returning nothing, so void, and it's a public method. So, public void run. And we have also seen this try catch block in our previous lectures, and I have explained it there also. Here I am going to take it in a brief manner, that for 5 we have taken a counter for I is equals to 5 to I greater than 0, and we are printing that count, and while we are printing that count, we are actually kind of making that thread sleep for some particular time. So, here the time quantum we have taken is 500 milliseconds. So, we have written thread dot sleep 500, and we are actually within this for loop. This for loop will go for 5 times, starting from I is equals to 5 till I is equals to 1. So, it will print the counter value, that is the value of I, and in between while it is printing the value of I, it will make the thread sleep. Which thread I am talking about? The current thread through which it is running, or whose entry point is this run. So, the current thread will go into the sleep for some specific interval of time, which is 500 milliseconds here, and then it will again wake up. And how it is going to wake up, that we have seen in our life cycle of the thread, that we have already seen. So, here is the try block, and corresponding to this try block we have a catch situation which says catch interrupted exception. That means this the method which is called here, which is the sleep method, may throw some interrupted exceptions. So, that interrupted exception has to be handled with the help of the catch, and if it occurs, then we will say child interrupted, and if this catch is not going to be there, then this child interrupted will not be we can say will not be executed, and your program will go into direct kind of exiting by printing a statement that is exiting the child thread. So, here the child thread will be exiting. Now, the question which comes up in the mind, that whose child thread we are creating. That means, who is the parent thread corresponding to this child thread. So, we have seen this in our previous lecture also, that the parent thread will be the main thread, which is the thread kind of we can say is going to be the a thread which is always there, and all other child threads, unless specified as child of others, they are going to generated, they are going to spawned by using through main thread. So, here now the situation comes up that we have written one particular class, which is the new thread. Within that we have given one constructor, and that constructor is not just creating a thread, but also kind of starting the thread, and immediately this immediately following this constructor we have declared one entry point for the second thread, and that entry point is nothing but run, and this what is this run is doing, that is clear from here, and because this run is inside a try inside this run we have a try block, so corresponding catch block is also there. and this class, which is the new thread, is actually kind of ending here with the two methods. One is the constructor, another one is the run method. So that's the flow of the program, what I can say. Now then we have our class, which is we have named it as extend thread, and inside this class we are going to kind of we are going to look for our main method. So we have our main method, public static void main string args, and then we have a new we have created a new thread by calling the constructor of that class, which is the new thread class. So we have created an object, a reference type to this new thread, and now after that we are again having this try catch block, and within the try catch block we have done whatever we have done, the mechanism which we have done just now for the child. So within the new thread class, printing the counter by 5 and then making the sleep thread, making the thread sleep for some time was happening to this child thread which was just created. Here it is happening for the main thread. So we have that for loop, then system.out.println, along with the main thread we have I, and but the difference here is that main thread is sleeping for 1000 units of time, and the child thread was sleeping for 500 units of time, and again the catch has to be there, and finally this program is going to end by printing the statement, that is main thread exiting on the screen. Now the question which comes up here is, what could be the output of this program. Output of this program could be, you can see that there is a main thread which is kind of running a counter 5 times, and in between it is sleeping, and then within that main thread, or from that main thread there we have created one child thread, and that child thread is also doing the same thing, printing the counter for 5 times and also sleeping in between for some 500 milliseconds. So that's what it is. Now the output is actually going to be the simple as it was for our previous program, that there will be kind of child thread 5, then child thread 4, and in between some executions of main thread will be there. Actual output will essentially depends upon the execution environment. We cannot define here that there will be 5 of the child, then 5 of the 4, then 5 of the main thread. We can't define that. That depends on the execution environment, one which is going to get ahead in the race. But one thing which is for sure here is the main thread is going to be the last one which is exiting the program. That is, it is the main thread which is through which the program is going to be kind of exited. Now till this point we have seen 2 ways of creating the thread. One which we have seen in our previous lecture, which was implementation of runnable through implementing runnable interface, and one which is kind of by extending the thread class. Now there are 2 methods for the similar thing. Now definitely a query comes up that which is to be used when, or which is kind of, we can say, a better method, or which is better of these 2. So first of all, let me clarify here is that the thread class defines several methods that can be overridden by a derived class. But one method which is must to be overridden is run, and the same method is required when it is when the thread has been created by implementing the runnable interface. Now if things are going on in parallel, kind of simultaneous, then why 2 methods? Because one is by extending the class, taking the advantage of the inheritance concept. So if one is a programmer is not overriding any of the threads other method except the run, because run is compulsory to be overridden. So if it is not going to override any of the threads method, it is a good idea to implement runnable. Many programmers feels that on the the classes should be extended only when they are being enhanced or modified in some way. So if it just kind of overriding the method which is available in the parent class, and you are not adding any extra functionality into that particular class should not be kind of we can say extended. Classes can only be extended or inherited if they are going to be enhanced or I can say child class is going to enhance or modify in some way. If this is not, then one may say that you must not or you should not, I can say you should not extend the thread class. Instead use the simpler method, which is the implementation of runnable. One more important advantage here is that by implementing the runnable, the thread class does not need to inherit the thread, because one has to be taken. Now your new class or the child class is actually free to inherit a different class, because it won't be able to kind of inherit multiple classes in a naive way. It can inherit, but not in a naive way. So by implementing runnable, your thread class does not need to inherit the thread class, the parent thread class. So now the child class is free to inherit a different class, because that inheritance corner I can say is actually kind of blank. Now we have seen here in this till this point what all practical concepts from the programming point of view we have covered. One is in our initial programs we have seen that the main thread which is being created automatically, how are we going to control that main thread. That means taking the control by by creating an instance of it, and then calling various methods related to that particular thing. So that was the first thing, that is how to experiment with the main thread, because main thread is automatically created. Then in the next step we have seen that there is a main thread and we have created one particular child thread, and we have seen two ways of it. One way is to implement the runnable thing, and another one is to extend the class. But here till this point we have actually dealt into two threads only. One is the main thread and another one is the child thread. And now in our kind of what is the next topic, that is creation of multiple threads. So creation of multiple threads, that means so far we have only main thread and one child thread, but your program can can generate as many as threads as it needs. So that is what your creation of multiple threads is there, and let us see how this can be done. Here I have used the simpler idea of creation of threads, which is the implementation of runnable thing. So let us begin with this program. We have a class new thread which implements runnable, and then there we have used one string variable as name, and then object of the class thread. Then we have created a constructor in which that thread name has been passed. Here we could have used a constant string instead of the variable. That's up to you, and that method we have seen in our previous lecture. So here name is equals to thread name that we have assigned here. That means thread name is the variable which we have taken as the parameter to the constructor new thread. And now we have created t is equals to new thread this name. So, this line basically means that a particular reference variable which is of type thread and it is named as T, that reference variable has been created by calling the constructor of the thread class, which is being called with the help of new thread, and it is actually passing two parameters. One is this pointer pointing towards the current instance, and another one is the name, and that name is actually kind of given as the parameter of the constructor. And this kind of scenario we have seen in our previous situations also. And then we are printing that new thread, that whatever information is available inside, whatever printable information is available inside this thread T, that we have printed, and then we have started the thread by calling T dot start. So, this is now again the entry point for the thread is the public void run, which is the run method, and then the similar kind of I can say loop for the purely the purpose of demonstration thing. We are printing the name, whatever name is of that thread, and then we have printed the counter. Now, here this is going to be the name of the thread which is going to call this run method, or on which this run method is going to be called. And now, as we are saying that this program is particularly there for calling the multiple threads, then obviously if we are going to create 3 threads here, then for all the instances this name is going to be different. This is what we are going to do, and then we have made that thread slept for let us say 1000 milliseconds and also, and then that catch interrupted exception is there, but here also we have used that variable name and then interrupted, and the moment one particular thread is exiting, we are going to write the name of that thread plus exiting, so that we are able to observe the situation or observe the whole status of this multi-threading instance, that what all particular threads are being created, how they are being executed, how they are sleeping, then getting awake, and then after completion of their functionality, what is being told to them, they are exiting. So, in order to kind of observe the whole scenario, we have used that name thing along with the exiting, along with the interrupted, and then along with the I can say loop, that counter printing thing also. Now, we have a class in which we are going to define our main method. So, within the main method we have taken, or we have created 3 threads for 3 threads which are being named as 1, 2 and 3. So, for that we have created new thread, that is by calling the constructor of the class new thread with the keyword new. We have used string 1, then this one string will be kind of saved in the parameter which is named as name name of the constructor of the class new thread. And similarly for the next 2, which is new thread 2, and then the third instance in the name of 3. So, here what we have done, we have actually created 3 threads named as 1, 2 and 3. Now, we are going to actually kind of start our or we can say main thread. So, within that main threads try catch block, we have written thread dot sleep, let us say for 10,000 seconds. So, this thread dot sleep for 10,000 seconds will make main thread wait for other threads to end, because this thread dot sleep is actually for the current thread, and presently the current thread is the main thread, and then we have written main thread exiting. That means deliberately we have kept main thread waiting for other threads to end. And again, a disclaimer that output may vary, or output will definitely vary based upon the specific execution environment. Even if in the same on the same machine you are trying to run this particular program multiple times, it may give you kind of different outputs every time. So that the output is shown on the screen. I can say a tentative output is shown on the screen, which says 3 threads has been created, 1, 2 and 3. And what is the significance of this number 5, that I will be telling you when I will tell you about the priority. Then for 1, 2, 3 the counter 5, then for 1, 2, 3 the counter 4. Then again for 1, 2, 3 the counter 2, 1, 2, 3 and then this is still 1. Now, why it is all happening in such a way? Because we have kind of we have not given anything to be done inside the main thread especially, and also the main thread is sleeping for 10,000 units of time or 10,000 milliseconds, I can say. So, here it is kind of all the 3 threads have completed their execution, that is from starting from 5 to 1 they have printed the counter, then 1 is exiting, 2 is exiting, that 3 is exiting, and then finally your main thread is going to exit. So, this is what kind of it is that we have what we have seen in this program is we have created 3 threads, and all these three threads are operating as the child thread of our main thread. So, in this lecture we have covered majorly 2 sections. One is creation of a thread by extending the thread class, and another one kind of a multi-thread demonstration of a multi-thread process in which we have created 3 threads, and along with those 3 threads one main thread was also operating. So, this is what we have seen in this lecture, and this is the list of references which is being used for the preparation of lecture. Hope you have enjoyed one. I will see you in the next lecture. Till then, take care. Goodbye.